Integrals involving trig and natural log. Someone asked me yesterday, they didn't like the test. Maybe you didn't like the test either. But like, is the next unit harder or easier? And I thought about it and I said different, which isn't helpful, I suppose. But the last unit was very conceptual. Lots of concept things, reviewing, if f prime is positive, that means f is increasing. Taking derivatives of exponents, derivatives of logs get you back to the original. Derivatives of integrals get you back to the original. Integrals of derivatives get you back to the original. Very concept oriented. This unit is back to learning new integrals, like what's the integral of a natural log, what's the integral of sine and cosine, and so it's equally hard, I think, but it's less concept and more process, more know the rules. And so I don't know if that's good news or bad news, but that's, I think, the difference between last unit and this unit. So having said that, we need to learn some rules. Some of these rules we know. So the book presents these like they're new rules, but if we think about them, I think we know this. So this isn't like a memorized situation right here. What's the antiderivative of sine of u? Now, be careful. Negative cosine. No, I don't think that's one we like separately memorize, because we know the derivative so we can go back and forth. How about the antiderivative of cosine of u? Tierney, how about the antiderivative of the cosine of u? Good. Sine of u plus c. Again, we know that already. We don't need to memorize that. But this section in the book presents all 6 trig functions like, hey, here's 6 new things you have to memorize. And I'm thinking, no, I know those already. The other 4, okay, those are new. But those first 2 at least I know. Antiderivative of tangent of u. I'm not going to pull a popsicle stick for this one because you probably don't know this one. No, because the derivative of tangent is secant squared. The derivative of secant is secant tangent. If you wanted to do this one, here's how you come up with the answer. But this is actually better than this, because this could be a u substitution problem. If u is cosine, du is sine, you end up with 1 over u.
Is that the natural log of absolute value?
Of which one? Of cosine. The one in the bottom. And that's kind of how this is one that I sort of have memorized. I don't remember exactly which way it goes, but I know that if I rewrite it as sine over cosine, and I let u be the bottom, then du is the top, and I end up with du over u, which is natural log. Oh, and a minus sign to account for the cosine. Now, so some people kind of go through that every time. Other people just straight up memorize integral of tangent as negative natural log of cosine. Now, this one you might be able to figure out based on all the other relationships of derivatives of trig functions, because it follows kind of that same pattern that we wrote 100 times already. Anybody want to take a guess at what the integral of cotangent of u is going to be? It's positive. Natural log of sine. So those kind of go together, right? Because it's again the same thing where change the signs and change the co or not co to get the sort of the partner integral, the partner antiderivative. I guess I would star the first one and sort of know how to get to the second one. All right, now this one really is more like straight up memorized because you can figure it out, but it takes a lot longer and it's a lot more work. This one is the natural log of secant of u plus tangent of u. It's real easy to show how it works. Like if you take the derivative of this, it eventually gets to secant, like within 2 or 3 lines. But it's a little bit trickier to go backwards, so this is one of those. It's like, well, go look up a YouTube video if you want to see how to derive that. Most of you, though, are just going to put it on a note card and memorize it. And once again, if you know the first one, you can probably guess the second one. This one I don't feel bad picking on somebody. Mark, what do you think the antiderivative of cosecant is?
I have no idea.
So how did we get from tangent to cotangent? We added a co. We changed whether it was co or not. On the other side, we changed the sign and we changed the co or not co. So on the left side, we changed the co or not co.
So it's going to be negative.
Yep. What do you think is going to be on the inside? Change whether it has a co or not.
Is it cosecant and cotangent?
Yep. So again, then if you add a co, then you change all the co's to not co's or not co's to co's, and you put a negative on there. So big picture, that looks like 6 new integrals to learn. I'm thinking it's really more like 2 new integrals to learn because you already know the first 2. I feel pretty good about those. The tangent and secant, those are new, those are different. You have to know those, and then you can figure out the other ones with the co and the minus sign. All right, integration with natural log. The short story is lots of u substitution. So the first main rule, going backwards, this is why we did the warm-up. The derivative of a natural log is 1 over u du. So the antiderivative of 1 over u du is back to natural log. The trick is, or the I guess difference is there's an absolute value on u because you can't log a negative number, and as always the plus c. So I'll star that one, although I'm not sure that one's new because we know the derivative, so we should be able to go backwards. All right, let's do some examples here. Antiderivative x squared over 3 minus x cubed. Again, we pick u so that du shows up, or something like du shows up. So I think we're pretty good at that. Any guesses on what u should be? Pardon? So if you pick x cubed, you can do it with x cubed, but you may as well grab the constant as well. because when you take a derivative of the constant, it's going to go away anyway, so you may as well include it in your u. So du is negative 3x squared. So that's a good pick. So what do I need to do to the top to make this work? Yeah, I need a 3 or a negative 3, I guess. And then a negative 1/3 out front. Several problems kind of like that on the test yesterday. I think one was a 6, one was a 4. Maybe depending on what version you had. So negative 1/3 antiderivative of all that stuff is du 1 over u. Well, there's a whole lot of that today. The antiderivative of 1 over u du is what? That's the natural log. Natural log of the absolute value of u plus c. Negative 1/3 still there. So negative 1/3 natural log 3 minus x cubed plus c. So that one didn't have any trig in it at all. We'll get to the trig in a minute. That was the natural log type problem. Number 2, antiderivative of 4 over 3 minus 6x dx. Similar problem, similar enough where I think I'm going to let you try that one. So negative 3 over 2, because that would get you to 6, and then a negative 2/3 out front. That's not how I was going to work that problem, but what you did was fine. I was going to work that problem by just moving the 4 out front to begin with and not having to worry about the weird fraction it would be. And so I need a negative 6 in there and a negative 6 out front. And you end up with, I mean, it works the same way. You get negative 2/3 in front regardless of how you get there. So this makes negative 6. Obviously that makes negative 6. If you make it that far, you're just about home free because it's now the same as it's been. Let's see, so negative 2/3, natural log, absolute value. I'm going to skip a step. U is equal to 3 minus 6x plus c. Okay on that one? Getting that constant to work out. Kind of a pain. But that's, so the natural log ones, you almost always end up with integral of du over u. Like, so that would be a boring lesson. I mean, a good lesson, I guess, for you, because they sort of all end up the same. That's why we throw some trig in there to keep it interesting, right? We don't want a boring lesson where we do the same thing the whole time. Antiderivative of cotangent of 3x dx. Okay, there's a rule for antiderivative of cotangent. It's on the other side of the paper, so I'll look it up in a minute. But I don't really like the 3x. So the antiderivative can handle the cotangent. How am I going to handle the 3x? We can let u be 3x. du is 3 dx. So this is just fixing a constant. We can handle that. So 1/3 integral cotangent of u du. Okay, this is one of those places where I have the integral of tangent memorized. That's natural log of cosine. So this one is the other way, the negative natural log of sine. Isn't it?
Negatives on the tangent.
Was the negative on the tangent? It sure was. So I get for not looking at my... So I had... I did the transformation right, but I had the original wrong. The original one has a negative. The tangent has a negative. Cotangent does not have a negative. And if I had written this as cosine over sine, I might have figured that out as well. Because u would be sine, du would be cosine, and so it's natural log of sine. So maybe you can see why we put the trig stuff with the natural log stuff, because it turns into a u substitution problem. Plus c, and don't forget to put the u stuff back in there. So there's my answer. Number 4. Cosine of x, integral of cosine of x over 2 plus sine of x dx. So that doesn't like directly fit one of those trig integral properties. Any ideas on what we could do with this one? Let u be 2 plus sine of x. And again, hopefully you're good enough to, as you're thinking about u, that you pick u while you're thinking about du. And that's hard to do. It's like, well, how do I know what du is without picking u? Well, you sort of identify a possible u, do the du in your head and see if it makes sense. I'm going to assume that's what Connor did, because what's du equal to? Cosine of x. Which is great, because that's what the numerator is. So we put that stuff together to get du. You You're going to see this a lot today. What's the integral of 1 over u du? Natural log of the absolute value. Again, I'm going to go ahead and substitute u in on the fly here. Plus c. That one didn't have any constants to fix. No negatives to worry about. That was pretty straightforward. There is one minor issue on this that's a perfectly acceptable free response answer. On a multiple choice test, it might write it like this. So the first question is, how are those even different? Subtle difference there. What's the difference? The absolute value sign. Why is it not needed? Do you know? It's not negative. 2 plus sine of x is always going to be positive. So that's a really minor difference. And on a multiple choice test, they wouldn't give you both of these answers anyway, because they'd both be right. But if you're working the problem, you get here, you look at your answers, and there's not absolute value bars. Hopefully, at least enough of your brain says, wait a minute, something's going on. Most of you probably say, well, close enough, I'm going to circle that one anyway. And you'd be right, but I want you to understand why you're right. 2 plus sine of x is always positive. So, again, it's rarely going to matter, because if it's free response, you'll stop here and be fine. If it's multiple choice, this answer won't be there, and you'd pick that one anyway. But the reason is, absolute value of a positive number means you don't need the absolute value bars. Got to do 2 quick ones and then 1 long one in 15 minutes. I think we can do that though. Antiderivative of 1 over cosine squared tangent x. This one you need to know your trig properties, your trig derivatives pretty well to make sense of this one. Any thoughts on what u could be, should be, might be, ought to be? I mean, I'd say there's only two options, right? It's either tangent or it's cosine. Why tangent? Some hand waving there. What's the derivative of tangent? Whoa, not... No. The derivative of tangent. If you're picking u to be tangent, then you got to take the derivative of tangent. Secant squared. Oh, I don't have secant squared. But I kind of have secant squared. Kinda. What do I mean by kinda? Where am I talking about? Yeah, 1 over cosine squared. That is secant squared. So this involved a trig identity. I don't remember those. The cosine is 1 over secant. Surely you remember that one. Surely? Maybe? That's what we're doing in pre-cal right now. Some of the posters around the room might even have that written on it somewhere. Well, once again, we get down to integral of 1 over u du. So natural log absolute value of tangent of x plus c. Tricky, sort of. Maybe not sort of, maybe definitely. Number 6, natural log of x all to the 4th over x dx. Well, I have no idea, so clearly I've got to find a u and a du to make this a simpler problem. It's not a whole lot of options for you. It's kind of the only choice, right? I've said before, if you let u be x, that doesn't do anything for you. It changes all the x's to u's, and then you still have the same problem with u's rather than with x's. So don't ever say u equals x, because that won't get you anywhere. So sort of our only other choice is to let it be natural log of x. I don't think I want to make it to the 4th, because if I make it to the 4th, du becomes a complicated mess. Right? I want you to take out some of the ugliness of the problem, but I probably can't use it to take out all of the ugliness of the problem, because then my du gets too terrible. What's the derivative of natural log? That's what we did in the warm-up to start the day. 1 over x. Is that good news? Yeah, because we have a 1 over x already. An x in the denominator. It's not written as 1 over x, but an x in the denominator. That's a great example of a u du problem that looks terrible. You make the right pick for u, and you got a really easy antiderivative. And I called it really easy, and then I'm going to call on somebody and put them on the spot. Emily, what's the antiderivative of u to the 4th? It's only hurtful if you don't get it right. No pressure.
Okay, so it's the natural log.
No, we're done with natural log, right? Yeah, we're done.
I am. No, I thought.
Oh, are you substituting already?
That's what I was trying
You can do that.
Oh, no, you have to do the, never mind. You do the power rule.
Yes.
5, you divide by 5.
There you go.
Sorry, I was like,
Put you on the spot. But that's it. It's a power rule. So up the power by 1, divide by the new power. That's not our final answer, but now we just put natural log of x back in for u. Don't forget the plus c.
What is natural log of x?
I promise I know how to do power rule.
Yes, sure.
I just know how weird that is.
Yeah, that's the same thing as that. But yeah, when you do use substitution, the whole point is you get rid of the junk and you make an easier problem, and then so you don't worry about the junk. Do the easy integral, and then put the junk back in.
No, I know.
You were trying to
I
handle it all at
assumed
once?
You had called me for the hard stuff, so it's like, oh.
I called you for the easy stuff. All right, last one. We have 10 minutes left. We might need 8 of it. Integral, or antiderivative, of x cubed minus 6x minus 20 all over x plus 5 dx. We could mess around with this, and I could ask you for some suggestions for you, but nothing's going to work. It's a short answer. If I let u be x plus 5, then du is just 1. That doesn't really help. If I let u be this entire top, then du is 3x squared minus 6. That doesn't do anything for me either. There's something going on in this problem, and that is if the top degree is greater than or equal to the bottom degree, do you remember the saying top no, bottom O equal co? That was for limits. Limits as x goes to infinity. So that's not what this is. But the top oh no is sort of what's going on here. If the top is bigger, then we get to divide. Like divide the top by the bottom. Algebra 2. We can do long division, but we could also do synthetic division. Synthetic division. Anybody have any idea how to set up synthetic division? Okay, we're so I need the coefficients. I picked one that had a missing x squared term, so remember that was always one of the hard ones on that test. Like, pay attention, if there's a missing term, put a 0 in there. What number is going out here? What number am I dividing with? Do you remember? I mean, it has to do with this. But what number goes out there? If x plus 5 is a factor, what would the 0 be? So we got to change that sign to do. You haven't done this in a long time, is right. That's correct. I think you did it at the beginning of last year.
I don't really remember doing it last year. I think we did it in like geometry.
No,
Algebra
this-
I know you did it in Algebra 2,
I know we did this last year at the beginning.
but I think you do it in the beginning of pre-cal. Like, I should know, I teach pre-cal, I'm teaching it this year, but 6 months ago, you know? So what do we do? Yep. And then add. By the way, that add subtract thing, usually when you're long dividing, you draw the line and change the sign and subtract. The reason you don't have to subtract here is because we made this negative. That's why they did that. We never really talk about that. So if you wanted to put a plus 5 there, then you could subtract, but let's don't do that because nobody does it that way. Multiply, add, multiply. Oh, that's not any fun. Add. But so what? Like, what does that mean? What do those numbers?
Is there something where you box the last one?
Though there is something special about the last one. That's true.
You drop the degree, so it's like x squared minus 5x.
You drop the degree, right? If you did x squared divided by x, or excuse me, x cubed divided by x, you'd be down to x squared. But we still got that last one. What?
Put it over the top.
So there's a couple things. One, you could say it's the remainder, but that doesn't really do us any good for this particular problem. It is the remainder, but we can put it over what we divided by. Sort of like when you're long dividing in 3rd grade and you get 3 left over. Well, I guess in 3rd grade you probably just say R3. In middle school you say 3 over 8 or 3 over 7 or whatever.
We did long division in 4th grade. Right? I know which teacher taught me that.
Do you really?
Yeah, Miss Bryant, she really did not like me. She stepped on glass, and low-key, I was happy. I'm right.
He's right. In 3rd grade, my mom taught me long division, and my teacher was like, "Don't use it." And I was like, "Okay."
All right, so back to the big point of this problem. In algebra, all you did was long divide. Hey, there's our answer. We're done. Now we did this whole algebra problem, and now we get to move back to calculus and say, oh, now we get to integrate that.
I don't think this helped.
What?
This equation still looks scary.
Well, I can integrate x squared, right?
Yeah, you could integrate.
Now that last one looks a little scary, but the first 3 we can do, right? I think. That's power rule stuff. That's the easy part. Now, last part, maybe we should slow this down a little bit. I'm going to put the 115 out front, make this 1 over x plus 5 dx. That way the 115 isn't messing with me.
What is just like, you use x plus 5 and then it's just 5. No, never mind, just 1. What? Can't you just use substitution for this?
Yes, what do you want your u to be?
Well, if it's x plus 5,
Uh-huh.
you just get 1.
Yep. And so you end up taking the integral of 1 over u du, which I feel like we've done 5 times already today. So x cubed over 3, 5x squared over 2, 19x, minus 115, natural log of x plus 5. Don't do all that work and then miss 1 point on this. Plus c. I'm not even sure I'd take off a point on that if you made it that far on that problem. Sometimes if a problem's like a 4-point problem and it's that hard and you leave off the plus c, I'll just write plus c. We're good.
I tried to show like 6-year-old me this.
Yeah, 6-year-old or even elementary school you, right? You'd be like,
Or even like
Just for fun.
all right, page 334. The odd applies to all of that and omit 43. So I'm trying to narrow down. I don't want to just say, hey, do all the odds. Like, I'm trying to target to get a little bit of everything without completely swamping you. If you're calc chatting, this is 5.2. I also posted some answers already worked out in my handwriting. I mean, it's maybe the same as calc chat, but maybe I show more steps. Sometimes calc chat jumps around and you can't figure out what's going on.